Shaitan Rajim Bismillahirrahmanirrahim. Dear student, Assalamu alaikum. Today, what we are going to do, chapter number class 10, subject physics, geometrical, chapter number 12, geometrical optics. As we are doing, we have already covered 12.1 and 12.2 articles in our last lecture. Today's topic of today's lecture is 12.3 and 12.4, pages covered 40, 41, 42, and 43. We will cover these four pages today. Again, class 10, subject physics, chapter number 12, geometrical optics, we are doing. Topics of today's lecture 12.3 and 12.4. We will try to cover these two topics. Pages covered 40, 41, 42, 43 of your 10th class textbook. So, this is a chapter we are doing, Unit 12, Geometrical. The name of the chapter is Geometrical Optics. Unit number 12, Geometrical Optics. This is the chapter we are doing. The name of the chapter is Geometrical Optics. In the last lecture, we discussed laws of reflection and phenomena of reflection, and we discussed about spherical mirrors, concave mirror, and convex mirror. And then we studied about poles, center of curvature, radius of curvature, principal axis, principal focus, and focal length. And reflection of light by spherical mirrors, we discussed about two types of regular reflection, irregular reflection, and laws of reflection and refraction of light. In our last lecture, we discussed all the six. We discussed the 12.1 and 12.2 topics in our last lecture, but today's lecture we will discuss about 12.3 topic. The 12.3 topic is image location by spherical mirror formula. 12 point, the topic of today's lecture is 12 point. Today's topic are 12.3 and 12.4, but I will start first 12.3. The topic name is image location by spherical mirrors. I told you last lecture there are two types of spherical mirrors. One is concave mirror and one is convex mirror. Concave mirror and convex mirror, they are related with the P, Q, and F. We will discuss about the relation between P, Q, and F, and we discussed about this formula 1 over F is equal to 1 over P plus 1 over Q. This is called the mirror formula. 1 over F is equal to 1 over P plus 1 over Q. This is called the mirror formula. What is mirror formula? Mirror formula is the relation between object distance, and object distance is denoted with P. Image distance is denoted with Q, and from the mirror, and the focal length is denoted with small f. Not focus, it is the small focal length. So focal length is denoted with small f of the mirror. So thus we can write the mirror formula. This is very, very important formula. 1 over f is equal to 1 over p plus 1 over q. So we will use this formula many times in our numericals. In our numericals, we will use this formula. So you should memorize them by heart. So 1 over f is equal to 1 over p plus 1 over q. We will use this formula in our when we will read lens topics. So now we are discussing about the mirror, but when we discuss about lenses, we will use the same formula. 1 over f is equal to 1 over p plus 1 over q. But since we are discussing about the concave mirror and convex mirror, the formula is same. 1 over f is equal to 1 over p plus 1 over q, where f is the focal length, p is the object distance, and q is the image distance. So object distance, image distance, and focal length are related with each other with the formula 1 over f is equal to 1 over p plus 1 over q, and this formula is called mirror formula. Mirror formula is the relation between object distance p, q, image distance q, and from the mirror, and the focal length f of the mirror. Thus, we can write the mirror formula 1 over f is equal to 1 over p plus 1 over q. Equation 12.1, this is the name of the equation 12.1, is true for both concave and convex mirror. This formula 1 over f is equal to 1 over p plus 1 over q is equal to is true for both concave and convex mirror. However, following sign convention should be followed to apply this equation for solving problems related to mirror. So the formula is same for concave mirror, whether it is a concave mirror or convex mirror, as we discussed in the last lecture. But there will be the sign convention, the focal length, the object distance will be positive, negative, or the image will be negative or positive. It depends what mirror we are using. If we are using concave mirror, so if we are using the concave mirror, so object P with distance will be P. If we are using the concave mirror, the object distance will be taken as P will be positive, Q will be positive, and focal length will be positive if we are using concave mirror. But if we are using convex mirror, so our focal length will be negative. So you should be very careful uh, when we use this formula. So if we are using concave mirror, all things will be positive. If we are using convex mirror, the all things will be negative. Focal length P and Q will be negative. We will discuss this, which will be negative, which will be positive in our numerical test, right? So I discussed about this formula. This formula is 1 over f is equal to 1 over p plus 1 over q. This is called the mirror formula, where p the object distance, q the image distance, f is the focal length. So these are related to each other with the formula 1 over f is equal to 1 over p plus 1 over q. This formula 12.1 is true for both concave and convex mirror. However, following sign convention should be followed to apply this equation for solving problems related to mirrors. If you have the problem related to mirror, so you will use which thing will be positive, which thing will be negative. I will tell you when we discuss the example of related to this formula, mirror formula. So you should know, up till now, you should memorize this formula. 1 over f is equal to 1 over p plus 1 over q. And p is the object distance, q is the image distance, and f is the focal length. Okay, so you should memorize this formula. 1 over f is equal to 1 over p plus 1 over q. We will use this formula so many times in problems and examples. So you should know this by heart. You should know 1 over f is equal to 1 over p plus 1 over q. Now we solve example 12.1. Convex mirror is used to reflect light from an object. This example is on page number 41 of your 10th class textbook. Example 12.1, I read the statement of the example 12.1. A convex mirror is used to reflect light from an object placed 66 centimeter in front of the mirror. The focal length of the mirror is 46 centimeter. Find the location of the image. So what is given to me? So this is the convex mirror. So in convex mirror, if we are talking about convex mirror, focal length P, focal length will be negative, focal length will be negative, and image will be, I will show you now. So whenever if you arrange this formula, since I want to find out the image distance, so if you use this formula, 1 over f is equal to 1 over p plus 1 over q. So if you separate out, so what will be 1 over f minus 1 over p will be, if you want to separate out 1 over q, so 1 over f minus 1 over p. So 1 over f minus 1 over p. So since focal length is, since it is a convex mirror, since a convex mirror, focal length will be negative. So I told you, whenever you have a convex mirror, the focal length will be negative, right? So you just put the values. Uh, f is f will be minus 46. So I will write minus 1 over 46, and p is 166, 66. So I will write 1 over. You don't need to convert this into centimeter into meter. So these are very, very small distances. Object, image, and focal length are small. That's why we will remain it in centimeter. We will not convert this into meter. As we know that SI unit of the distance is meter. But in this numericals, in this chapter, we will not convert centimeter into meter. So since focal length, image, and Q are already very small things, okay. So 1 over f is equal to 1 minus, this is the formula. I separate out 1 over q. This formula this formula 1 over f is equal to 1 over p plus 1 over q. Just separate out 1 over q, taking 1 over p on this side. So 1 over f minus 1 over p. So just f is, since f is given to me 46, since it is a convex mirror, so f will be, focal length will be negative. That's why I'm putting minus 1 over 46. So 1 divided by focal length is 46. So minus sign is due to the focal length of the convex mirror is always negative. So that's why I'm putting minus 1 over 46. Minus same p will be 66. I'm just putting p. Taking the LCM, take the LCM, or you can either solve 1 divided by 46, 1 divided by 66, then add them up. You will get minus 1 over 23. If you take the LCM, so you will take the LCM, you will get minus 1 over 27. Since we want to find out Q, so reciprocal of this 1 over Q and 1 over 27, or cross multiply this 27 or Q multiplied by 1 is Q. So if you cross multiply this, Q equals to minus 27 centimeters. It means image distance is minus 27 centimeters. I told you in convex mirror, focal length will be negative and Q image distance will be negative. And what kind of negative sign indicate the image is behind the mirror, and therefore it is a virtual image. It is a virtual image. In my last topic, I told you about what is the convex mirror. So outer surface is reflecting and the surface is polished. This is called convex mirror, and so the image will be virtual in this case. This is not a real image. This is a virtual image. So negative sign is indicated. The image will be virtual image. So negative sign indicates that the image is behind the mirror, and therefore it is a virtual image. And when I discussed about this is the convex mirror, the image virtual image will be found, and virtual object will be virtual object, and image will be virtual image. That's why Q negative sign indicate that the image is behind the mirror and is a virtual. I repeat this example. I told you this formula. This is called the mirror formula. Mirror formula is a relation between object distance p and image distance. Image is denoted with small q, object is denoted with small p, and focal length is denoted with small f. So 1 over f is equal to 1 over q plus 1 over p plus 1 over q. You should memorize this by heart because we will use this formula so many times in the numericals and examples. So you should be very careful and you should memorize this by heart. 1 over f is equal to 1 over q plus 1 over q. 1 over p plus 1 over q is true for both concave and convex mirror. If it is a concave mirror, you will use the same formula. If it is a convex mirror, you will use the same formula. But when we discuss lenses, we will use the same formula as well. So this formula is very important. This is the heart of this chapter. This formula 1 over f is equal to 1 over p plus 1 over q. 1 over q is the heart of this chapter. You should be you should memorize this by heart. Okay. So I discussed this formula. This is called the mirror formula. So we have two types of mirror. So one is called the concave mirror and one is called the convex mirror. So in case of concave mirror, image will be real, object is real, image is real, and the P is positive, Q will be positive, and F will be positive. But in case of focal length will be positive if the mirror is concave. But if the mirror is convex mirror, so our focal length will be negative and Q will be negative as well. So as we discussed this example using this formula, so I convex mirror is used to reflect light from an object placed 66 centimeter. So object means P is given to me. Object placed means P is given to me, which is 66 centimeter in front of the mirror. The focal length is also given to me, which is the mirror is 46 centimeter. So focal length will be taken as negative because the because the mirror is convex mirror. So focal length will be taken as negative. Okay, remember this focal length is always taken negative whenever the convex mirror is used. Okay, so you will use this formula. I arrange this formula. I arrange this formula 1 over f is equal to 1 over p plus 1 over q. So separate out, since we want to find out the image distance, so separate out this one. So 1 over f minus 1 over p. So 1 over q is equal to 1 over f minus 1 over p. Just plug in the values. F is given to me, which is 46 centimeter. So you don't need to convert this into meter because focal length, object distance, and image distance are already very small. So you don't need to convert this into meter because meter will be the bigger unit. So we will take centimeter. We will remain this in this chapter. We will most of the time we will be remain in centimeter. So 1 over f is equal to, just to plug in the value 46, minus is due to the convex mirror, 1 over 46 minus p is 66. Just put the value and take the LCM. You will get minus 1 over 27. So since we want to find out q by taking the cross multiplication, 27 will be multiplied with 1. So q will be multiplied with 1. So q equals to minus 27 centimeters. This q is the image distance which we are required. So this negative sign indicates the image is virtual image and this is behind the mirror. So this is the end of the example 12.1. Now we discussed example 12.2 now. Example 12.2, I read this example first. An object is placed 6 centimeters in front of the concave mirror that has a focal length 10 centimeters. Determine the location of the image. Here we want to find out Q again, but this time not convex mirror, it is a concave mirror. As I have already told you, in concave mirror, focal length will be positive, P will be positive, right? And Q will be positive as well. All the things F, Q, and P will be positive. But in this case, in this example, we are talking about concave mirror, and in concave mirror, focal length Q and P will be positive. Remember this, okay? So an object is placed means P is given to me. P is 6 centimeter and the focal length is given to me 10 centimeter. Determine the location of the image. So we need to find out Q. Again, so given data P is 6 centimeter, F is 10 centimeter, as I already told you, P will be 6 centimeter and F is 10 centimeter. Okay, so I will use the same formula and arrange it 1 over Q is equal to 1 over F minus 1 over P. So focal length is 10 centimeter, P is 6 centimeter. So if you take the LCM, your image will be minus 15 centimeters. The negative sign indicates the image is virtual. Whenever the negative sign comes, it means the image is virtual behind the mirror. Okay, so concave mirror, this is the formula for this is to find Q, image distance. So Q is minus 15. Whenever you see the Q negative sign with Q with value, whenever the Q will come with negative sign, it means the image is virtual and is behind the mirror. You should write negative sign indicate that the image is virtual and behind the mirror. So student, in this example, object is noted with P. P is given to me 6 centimeter. Is this possible? And focal length is taken as positive because this is a concave mirror. In case of concave mirror, P and F will be positive, right? To determine the location of the image, we need to find out Q. I will use the same formula as I told you. This formula we use 1 over F is equal to 1 over P plus 1 over Q. But since we want to find out Q, I separate out 1 over Q is equal to 1 over F minus 1 over P. Just arrange it and just put the values. F is given to me 10 centimeter and P is given to me 6 centimeter. If you take the LCM and it will come minus 1 over 15 centimeter. Here Q is coming minus with minus sign. So whenever the minus sign comes, it means image will be virtual and behind the mirror. Okay. Q stands for image, P stands for object distance, Q is image distance, and F is the focal length. But you should know focal length will be taken as positive when you are using concave mirror, and focal length will be negative when you are using convex mirror. This is the main thing we need to memorize. So this is the end of the topic 12.3. Now I'm going to start 12.4, refraction of light, which is on page number 42. If you open 10th class textbook, page number 42, you will find 12.4 topic, refraction of light. Now I am going to start refraction of light. I told you in my earlier lecture, we discussed the phenomena of reflection of light. But this topic, the reflection of light, what's the difference between reflection and reflection? You should know very clear. So whenever you talk the phenomena of reflection, and as I am talking about the last lecture. So in last lecture, we discussed about the phenomena of reflection. I told you reflection in reflection, whenever the incident light falls on the surface of the mirror and it reflects on the same medium, it is coming from air and going back to the air. When you have the same medium, this phenomena is called phenomena of reflection. But in case of refraction, as we are talking now, 12.4 related to 12.4 refraction of light. In this topic, we will discuss two medium, right? So one medium is air. So incident light is coming from air and it is going into the other medium, which is called the glass. This is the glass medium. So it is coming from air and it is going other medium, which is called glass. Whenever you have two medium or different medium, one is air, one is glass. So you say this is the phenomenon of refraction. This will not be the phenomenon of reflection because there are different mediums are involved. So in this case, air light is coming from air and is going into the glass. So there are the two mediums involved. So we will say the phenomena of refraction, not the phenomena of reflection. Okay. Whenever the same medium involved, you say phenomena of reflection. But whenever the different medium involved, as we are discussing now, you say phenomena of reflection, right? So, and light is coming from air, and whenever uh, it enters the other medium, like glass, this is the glass, okay? He's saying refraction of light by glass block. This is a glass block. This is a block of glass, okay? So light is coming from air and it enters into the other medium, which is called a glass of block. It This is the normal line. It bend away from the, it bend towards the normal, it bend towards the normal. So it is coming from air, it is coming from air and it is moving towards the normal. It is say uh, it will say laws of refraction, laws of refraction. So in this case, but as when we discuss about laws of refraction, in that case, angle of incidence equals to angle of refraction. But in this case, when we talk about refraction, phenomena of refraction, angle of incident will not be equal to angle of refraction. So angle I, in this case, angle I will not be equal to angle R if we are talking about the refraction of light. Because in refraction of light, two mediums involved. One is air, another is, in this case, one is air and other is glass, block glass. So whenever the light is coming from air, it will, when it enters the other medium, it bend towards the normal. So if we draw, why we draw the normal line? In order to find the angle of incident, angle of reflection. Angle of incidence is denoted with I, angle of reflection is denoted with R. So this ray is called incident ray. When it enters the other medium, it is called refracted ray. This arrow, IO is the incident ray, OM is the refracted ray, and when it leaves the and going back to the air again, it will bend away from the normal. So this line ME is called the emerging ray. But in this case, angle of refraction of light, angle of incidence is not equal to angle of refraction. Okay, so I read the phenomena of refraction. If we dip one end of the pencil or some other objects into water, as you can see, so at an angle to the surface, the submerged part looks bent as shown in figure 12.7. If you dip your pencil, you can do this experiment at home. Take a glass of water and dip a pencil in it. You will see that you will not see the pencil is same. You will see the bented pencil when you see into the water. Okay, so it is because the refraction phenomenon. It is bending of light. So its image is displaced because the light coming from the underwater portion of the object changes direction as it leaves the water. This bending of light as it passes from one transparent medium into another is called refraction. Because it's coming from air, so you will see this half part of the pencil is in air and other part is in the different medium. So that is water. So whenever you see this is in the water, you will see this is bented. So this is just because of the phenomena of refraction. Refraction of light can be explained with the help of figure 12.8. This is the 12.8 refraction of light. A ray of light IO. This is called IO is called the incident ray. From air falls on the surface of the glass block. So this is the glass block. This is the glass block. This is a rectangular block. Is called the glass block. This is made of glass. That's why it is called the glass block. Okay. So IO is the incident ray. When at the air the glass interfere, the ray the glass interface, the ray of IO changes direction and bends towards the normal and travel along the path OR. So it is traveling along the path and bends towards the normal. It is moving towards the normal. It is near to the normal. That's why OR is the called the refracted ray. The ray IO and Q are called the incident ray and the refracted ray as well. IO is called the incident ray and OR is called the refracted ray. Not reflected ray, it is refracted ray because whenever I'm talking about two mediums, so we will study the phenomena of refraction, not reflection. So refracted ray. OR is my refracted ray, IO is my incident ray. So the angle made by the incident ray is noted with small I, which is called the incident angle of incidence. The angle made by OR with the normal is called the refracted angle. Okay. So refracted angle is noted with small r and incident angle is noted with I. Ray with the normal is called the angle of incidence. The angle R made by the refracted ray with the normal is called the angle of refraction. When refracted ray leaves the glass, it bends away from the normal and travels along the path ME. As you can see, when it leaves the medium, leaves the glass, it bend away. Normal is my hair. If you draw the normal here, so it will bend away from the normal, and it is not with ME. This is called emerging rays. If we write the definition of the refraction of light, the process of bending of light as it passes from one medium to another is called refraction of light. This is the definition of refraction of light. So as we discussed, when we discussed the law of reflection, similarly we will discuss the laws of refraction too. In this case, first there are the two laws over there as well. In reflection phenomena, we have the two laws: angle of incidence equals to angle of reflection. But in angle laws of refraction, we have also two laws. The incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane. Look, incident ray, refracted ray, and the normal, they all lie in the same plane. Similarly, the same thing in the laws of reflection, the same thing is in laws of refraction. The only difference here, their incidence angle equals to angle of refraction. But in this case, angle of incidence is not equal to angle of refraction. So the ratio of, but here the other law, the ratio of sine of angle of incidence I to the sine of angle of refraction R is always equal to constant. Sine I over sine R, the ratio. This is called angle of incidence, sine of angle of incidence, ratio of sine of angle of incidence to the ratio of sine of angle of refraction. Angle of refraction is equals to some constant, and some constant is denoted with n. So sine I over sine R, this law is called Snell's law. This is the scientist name. Snell's law is the scientist name. Sine I over sine R is equals to n, which is called the uh, Snell's law. So it is called the Snell's law. Now, what we discussed laws of refraction. So this is the definition of refraction of light, and this is the law of refraction, not reflection. This is the law of refraction. When there is a two medium involved, then you say refraction, not reflection. When you have the same medium, air, it is going back to the air. This is called the reflection. So in reflection, Sine of I equals to sine of R, angle of incidence equals to angle of reflection, and incident ray, reflected ray, and the normal lies in the same plane. But if we talk about the laws of refraction, so the first law is same as in the law of reflection, but the second law is different. But the first law, the incident ray is refractive, but here refracted ray and the normal are at the point of incidence all lie in the same plane, as we discussed in law of reflection as well. But over there, sine I equals to sine R, but here the sine I is not equal to sine R. Here the angle sine of angle of incidence to the ratio of the sine of angle of refraction is equal to some constant which is n. This whole thing sine I over sine R is called the Snell's law. This is Snell's law. This is on the scientist name Snell's law. So sine of angle of incidence to the sine of ratio of sine of angle of incidence to the sine of angle of refraction, not reflection, refraction equals to some constant. This is called Snell's law. Now we discussed about the speed of light in medium. So you should be very careful because these things come, these tables come in the MCQ point of view. They ask you index of refraction. Diameter index of refraction is 2.42, cubic synchronia 2.21. So this is the different index of refraction you should know by heart. So index of refraction of ice is 1.331, and index of refraction of water is 1.33, and air is 1. Okay. So speed of light, now we discussed about speed of light in medium. So speed of light is different in different medium. So suppose, for example, the speed of light in air is 3 into 10 power 8 meter per second. This is the speed of light in air. But if the speed of light, if we talk about the speed of light in water, the speed of light in water will be reduced because it is going into the, in air it is very high, which is 3 into 10 power 8 meter per second. But if the speed of light is in water, pass through the light in water, it will be decreased, which is 2.3 into 10 power 8 meter per second. So speed of light depends on the medium. If the air is medium is air, then the speed of light is 3 into 10 power 8 meter per second. But if the medium is water, if the speed of light in water, it passes to the water, so it will be decreased. So it will be in water is 2.3 into 10 power 8 meter per second. Okay. So while in glass, speed of light is 2 into 10 power 8 meter per second. So it means different medium, different speed of light. So air, it is maximum 3 into 10 power 8 meter per second. If you take the water, 2.3 into 10 power 8 meter per second. If it is a glass medium, then it will be reduced to 2 into 10 power 8 meter per second. So to describe the change in the speed of light in the medium, we use the term index of refraction or refractive index. If we want to, different medium, they have a different speed of light. So in order to find out the different change in the speed of light in the medium, so we use the term index of refraction, or simply it is called refractive index. The formula to find the refractive index is refractive index speed of light in air divided by the speed of light in medium. So n equals to, refractive index is noted with small n, and speed of light in air is noted with c, which is 3 into 10 power 8, and speed of light in medium, other medium, water, glass, so c divided by v, n is equal to c divided by v. This is the formula for refractive index. And the term refractive index is used to find the change in the speed of light in different medium. If we want to find the change of speed of light in the different medium, we use the term refractive index, and it is noted as n is equal to c over v. N is equal to c over v. So this is the speed of light, refractive. This is the term refractive index. N of our medium is the ratio of the speed of light in the air, speed of light in the medium. So refractive index is equal to speed of light in air divided by speed of light in medium, n equals to c over v. So student, this is the end of the topic. Today's topic 12 point. We discussed about 12.3 and 12.4. In I gave you just a quick review what we discussed. So we discussed about image location by spherical mirror formula. We discussed about this, and the formula. This formula is called mirror formula, and it is the relation between object distance, which is p, image distance q, and focal length f. So 1 over f is equal to 1 over p plus 1 over q. This formula is called mirror formula. This formula is very important because this both apply for concave mirror or convex mirror or even in lenses. This formula 1 over f is equal to 1 over p plus 1 over q. This formula is very important. This is the heart of this chapter. We discussed about convex mirror and concave mirror. Focal length will be negative, Q will be negative if we are using convex mirror, and if it is a concave mirror, focal length and focal length will be positive, P will be positive. So, example we discussed about example 12.1. We use this formula since we want to find out the Q. So I separate out Q as I use this formula 1 over F equal to 1 over P plus 1 over Q. If I separate out 1 over Q, I take this on the other side 1 over F minus 1 over P. So our 1 over Q is equal to 1 over F minus 1 over P. Since this is the convex mirror, so that's why F is taken as negative. So minus 46 because of focal length is negative in case of convex mirror. So I use this formula cross multiply Q will be negative. This Q indicates that the mirror image is behind the mirror and therefore the image is virtual image. Then we discussed about 12.2. In 12.2 example, we consider concave mirror, and in case of concave mirror, focal length is positive and P is positive as well. I use this formula since I want to same thing Q image distance. So I separate out same formula. I separate out 1 over Q is equal to 1 over F minus 1 over P. F is 10 centimeter and P is 6 centimeter. Here F and P will be positive. Why? Because I am using concave mirror. In case of concave mirror, focal length will be positive and P will be positive. So if you separate out this, you will get Q image distance, which is minus 15 centimeter. So negative sign indicates the virtual. Then we discussed about the other topic, 12.4. The name of the topic was refraction of light. In refraction of light, we discussed about two medium. One, air is coming from air and it is going to other medium, glass. When there is the two medium involved, then the phenomena will be refraction of light. But when there is a one medium involved, it is coming from air, it's after reflection going back to the air again. This is called the reflection, a phenomenon of reflection. But when there is a two medium involved, it is coming from air and it is going into the glass box. A glass box is called phenomenon of reflection. So this is the so what happened? Incident rate IO when entered into the other medium, it bent towards a normal, and this is called OR is called refracted ray. IO is called the incident ray. So when it leaves the medium, it bending away from the medium. This is called emerging rays. Then laws of refraction, we discussed laws of refraction, incident ray, refracted ray, and normal, all point of incidence will lie in the same plane. Here's angle of angle of incidence to the ratio of sine of angle of incidence to the ratio of sine of angle of reflection equals to some constant. This is called Snell's law. Then we discussed the speed of light in different mediums. Speed of light in air is 3 into 10 power 8 meter per second. But speed of light in water will be reduced to 2.3 into 10 power 8 meter per second. And in glass, speed of light is 2 into 10 power 8. So this is in order to find the speed of light in different medium, we use the term refractive index, and refractive index is noted with N is equal to C over V, where C is the speed of light in air, which is 3 to 10 power 8, and speed of light in medium is noted with V. So N over C over V, this is called the refractive index. So students, this is the end of the topic 12.2 and 12.3 and 12.4 we discussed today. So I hope you understand this. If you have any question, please let me know. Thank you.